approximate values of floating point numbers. Here we're going to see a strange truth. When you add 0.1 plus 0.1, you do get 0.2. That's true. But when you add 0 plus 1 plus 0 plus 1 plus 0 plus 1 and see if you get 0.3, you do not, which is terrible. And the reason is because what you get instead is 0.3 and that little tiny bit. In fact, when we go ahead and take the difference of 0.1 added 3 times minus 0.3, we get this tiny number, 5.55 times 10 to the negative 17th, a very tiny number. So the problem is it's tiny, but it's not 0. So in fact, when you test double equals, this is going to fail because it means exactly equal. So you cannot trust double equals with floating point numbers. You cannot use double equals with floating point numbers. So if I have x is 0.1 plus 0.1 plus 0.1 and y is 0.3 and I want to test if they're equal, I cannot do that test right there. I cannot test if x double equals y. So what do I have to do instead? I have to test if they're nearly equal or almost equal. And for that, what I would wind up doing is I'll take some epsilon, say minus eighth. You can change that epsilon depending on the situation. And what I'd really want to test is if their difference, the absolute value of the difference, is less than that epsilon. And I go ahead and run this, and in fact, that's true. That means that they're really, really close to each other. And that's what we're going to take to mean basically equal for floating point numbers. This test is done so often that we put it in our own function called almost equal. And we'll go ahead and, of course, we don't want to print that. Now we want to return that. And now we can print if x and y are almost equal. And sure enough, they are. You can adjust the epsilon to whatever value suits you. Different problems may call for different epsilons. Almost equal is not built into Python. You're going to use it very frequently because this is how you test for equality with floating point numbers. But you're going to have to actually type this in each time you want to use it because, again, it's not built into Python. Let's look at one more strange case about the approximate value of floats. And it's this. If I were to print the round of 2.5, I would go ahead and I'd see it's 3, which is unsurprising. But let's do that again in standard Python. And I see that it's actually 2, which points out two things. First, that's modestly terrifying. Okay, but if I were to say 2.501, that would be 3. So what's going on is there's floating point error going on, and that 2.5 in standard Python is 2.499999999. And so that would round, of course, down. And in Python, it actually rounds up because you get a different, really close but different value. So we learned that in different implementations of Python, you might wind up with ever so slightly different values of floating point numbers. So you cannot ever trust that a floating point number is exactly the value you think it is. It's just really close. But that's also why instead of using equality, we must use almost equal in every case with floating point numbers.